Good morning, friends. Good morning to the channel Just Get Civil. So, today is the 26th lecture of this series. Before going to the topic details, first we need to know that what is there. So, we are for the crash courses for Mission Gate 2021. We are here for the crash courses of Mission Gate 2021. An academy, let's crack it. Crack Gate and ESC with India's largest learning platform. Get Plus subscription and access unlimited live and recorded courses from India's best educators. Don't forget to subscribe, and myself Soumyajit Sen. Those who have already done the classes, you know me. Go for the Unacademy Learning app first. If you have not installed yet, install it. There you will see lot many options for your desired examinations, what you need to crack, what you're planning to go for. And in the classes, what you will get daily live classes, structured courses, live test and quizzes, unlimited access. There's another thing which is called as iconic subscription, where you will get personal coach, study tracker, question answer practice, all benefits to PLUs. In the plus subscription, daily live classes, live test and quizzes, unlimited access, structured courses, you all get. The top educators you will get different languages. So you can go for plus subscription, or you can go for iconic subscription, but iconic subscription of course will be more beneficiary to you for your preparation process. And while taking the subscription, don't forget to apply, that is a plus plan. While taking the subscription, don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10 for maximum benefits. Don't forget to apply the code SEN10 for maximum benefits. Iconic subscription, once again, just reiterating the thing, that don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10 ACN10. Certain batches already been launched, like Evolve for Gate 2022 in English and Hindi, both for the civil engineering students. Starts on 28 December 11:15 a.m. If you are going for a subscription, don't forget to apply the code SEN10 over there. Then you can go for this Target EAC Prelims 2021 Batch A and Batch B, both the cases already launched on 11th January. But if you are going for these courses, don't forget to apply the code SEN10 ACN10.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Academy Combat, India's largest fortnightly competition for GATE. Challenging and original questions curated by best Unacademy educators. Super fast and fun with all India live leaderboard. See how you rank against others. It will give you an idea that where you are actually standing in terms of your preparation. Make it live to compete with the best. Identify and improve your weak areas with detailed video solution by top educators. And next combat will be live on 26 January 2021 6 p.m. And don't forget to apply the code SEN10 ACN10. Now we are going for the problems on primary treatment of wastewater. So today the 26th lecture of this wastewater engineering, of this environmental engineering. इससे पहले हम लोग सारे जितने टॉपिक्स हैं जैसे डोमेस्टिक वाटर सप्लाई का 9 चैप्टर्स, वेस्ट वाटर इंजीनियरिंग का 10 चैप्टर्स और उसके साथ साथ एयर पोल्यूशन और सॉलिड वेस्ट मैनेजमेंट, ये सारे हम लोग पढ़ चुके हैं पढ़ चुके हैं मतलब इन टर्म्स ऑफ वी हैव रेड इट द थियोरिटिकली कुछ कुछ चैप्टर्स का क्वेश्चंस पहले भी सॉल्व कर चुके थे, जैसे वेस्ट वाटर इंजीनियरिंग का आफ्टर एक्टिवेटेड स्लज प्रोसेस जितना भी चैप्टर था सारे चैप्टर्स का क्वेश्चन सॉल्व हो चुका था। ट्रिकलिंग फिल्टर, डिस्पोजल ऑफ सीवेज एफ्लुएंट, स्लज डाइजेशन, ऑक्सीडेशन पॉन्ड, सेप्टिक टैंक, सबका क्वेश्चन सॉल्व हो चुका था। जब रिवीजन करने के टाइम पे हम लोग आए हैं, वेस्ट वाटर फ्लो रेट्स हो चुका है, डिजाइन ऑफ सीवेट्स हो चुका है, इवन कैरेक्टरिस्टिक्स ऑफ वेस्ट वाटर इज आल्सो डन। Two things are left. One is primary treatment of wastewater, another one is activated sludge process. These two chapters question we will be solving today itself, and we will finish wastewater engineering completely for GATE 2021. I'll be taking one class for this marathon session for hydrology itself, completely a crash course on hydrology. Freaks will be there to solve the questions from hydrograph and all those things. And then I will take a special class for this brush up for environmental engineering also. Now, one thing, so before going to start the questions, one thing I can say that if you go for one particular class, that is a marathon session, which I have taken on 16th, that's which I have taken on 16th, that marathon session is a broader aspect brusher of environmental engineering itself. There I have dismantled each and every topics. Then what will be the weightage, what are the weightage, everything is discussed over there. You can go through that marathon session. You're going to get a proper view how to deal with the environmental engineering chapters. And in the app I am taking every day one sessions on those topics of environmental engineering, those generally left out from students due to the lack of concept. Those topics are getting dealt in the apps once again. Generally 9, 11, 11:30 I am taking a class. You can go to the app, follow me. There also you can solve your questions, push your doubt. Live classes will be there. Anyways, let's start the class for the problems on primary water treatment process. So first we are going for the question 1. Question 1. A grid chamber of dimension 12 meter cross 1.5 meter cross 0.8 meter liquid depth has a flow of 720 meter cube per hour. Find out the surface loading rate and detention time. Find out the surface loading rate and detention time. Now, before starting the questions, hope you remember the primary treatment process. Primary treatment things the all those class carefully. Just I am giving you an essence of that particular class so that you can just give you a glimpse of that classes. You can understand it, understand the problems. Not only you can produce it properly. This is the primary treatment process. In the treatment of wastewater, this is the treatment of wastewater scheme, where wastewater going for the screening, breed chamber and skimming tank, and then primary sedimentation. In the primary sedimentation, what type of sedimentation is observed? Primary sedimentation of wastewater engineering, type 3 settling process. Type 3 settling process. The screening, grid chamber and skimming tank is called as preliminary treatment, and along with the primary sedimentation, it is called as primary treatment or 1-degree treatment. Then it is going for the biological treatment, and each and every biological treatment, specifically aerobic treatment process, is accompanied by each and every biological treatment, aerobic treatment process is accompanied by what? It is accompanied by a secondary sedimentation tank, where type 4 settling process, or the compression settling or zone settling will be observed. In the type 3 settling के मतलब है कौन सा settling? You will be getting the essence of hindered settling. Primary sedimentation in the wastewater engineering, primary sedimentation tank में आपको क्या मिलेगा? Hindered settling. और secondary sedimentation में आपको मिलेगा क्या मिलेगा? You will be getting this zone settling or compression settling. Now, primary treatment means this skimming, this screening, the grid chamber and skimming tank along with the primary sedimentation unit. Primary treatment process screening. It is the first unit operation encountered by wastewater where large floating objects such as waste paper, plastic, cloths, glass bottles, wooden pieces are getting removed. कुछ नहीं है इसमें, just it is the obstacle to the flow, and the particles which is having higher diameter than the pore size will get restricted. That is there. Screens are of 3 types: coarse screen, medium screen, fine screen. This is, I am just giving you the glimpses, then I will go to the problems. Design parameter of screens is discussed. To make you understand, one problem is also discussed. Solve this question. Then we have gone for the grid chamber. What are the grid particles we have discussed? What is the design essence or design concepts of grid chamber is discussed. Settling velocity of then skimming tank. It's a special type of tank to remove the oil and grease particle from wastewater. Then primary sedimentation. So then we have gone for the activated sludge process that we will see after the completion of the few questions are there. After the completion of this question, we will see the activated sludge. Let's go for the question solving process. So a grid chamber having, so its grid chamber is nothing but a rectangular sedimentation tank itself. So 12 meter into 1.5 meter into 0.8 meter liquid depth has a flow of, so Q is given as 720 meter cube per hour. length is given as 12 meter, width is given as 1.5 meter, and height is given as 0.8 meter. L, B, and H are defined. What they're asking to find out surface loading rate, SLR. It's nothing but surface overflow rate, which is nothing but U by surface area. Q by surface area, where Q is equals to 720 meter cube per hour. Surface area is L into B, 12 into 1.5. So it's 40 meter cube per meter square hour. So this is 40,000 liter per hour meter square. Now detention time also they are asking. Detention time is nothing but V by Q, where V is 12 into 1.5 into 0.8 by Q is 720. That's in hour into 60. That will be in minute. How much it will be? 1.5 into 0.8 minute. It's 1.2 minute. Very easy to solve. Hope you understand the question properly. This is the first question. And previous question was ESC 1997. Now question number 2 we are going for. Question number 2 we are going for. That is also ESC 2002 at sewage treatment plant. For a flow of 3 meter cube per second, the cross sectional area of grid chamber will be about. Question number 2. How to solve these questions? Any idea? So see, a sewage treatment plant for a flow. So Q is given as 3 meter cube per second. Asking cross sectional area. So quite obviously, cross sectional area is Q by VH, where VH is the horizontal flow velocity. Now that value is not given, right? But the idea we know the ideal value for VH is 0.3 meter per second that you have to take. So cross sectional area will be Q by VH, which is 3 meter cube per second by 0.3 meter per second. Will be 10 meter square. That will be 10 meter square. Okay. Now question number 3. For a grid channel, if the recommended flow velocity is 0.25 meter per second and detention time is 1 minute, then the length of the tank will be question number 3. Question number 3, please solve. For this question, recommended flow velocity VH is given as 0.25 meter per second. Detention time is 1 minute. So if this is the tank and this is your length, obviously this is your VH. So L is equals to VH into detention time 0.25 into 60. It's 15 meter. 15 meter. Now we are going for question number 4. A circular primary clarifier processes an average flow of a circular primary clarifier processes an average flow of 5005 meter cube per day of municipal wastewater. The overflow rate is 35 meter cube per meter square day. The diameter of the clarifier shall be. The diameter of the clarifier shall be. Quickly solve this. So Q is given as 5005 meter cube per day. Eastward is given as 35 meter cube per meter square day. So surface area will be Q by SOR 5005 by 35 143 meter square. As is circular cross sectional area is told, so pi by 4 d square is 143. And d will be 13.5 meter. Yeah, it's correct radius, but they're asking for the diameter actually. Next question. The proportional flow weir at the effluent end of a channel type grit removal unit is to, four options are given: provide easy passage of solid particles, option B, measure the rate of flow in the channel, keep the depth of flow in the channel, maintain constant mean velocity in the channel. See, if you remember, when we have gone through the grid chamber discussion, I have told you the main motto is to control the horizontal flow velocity through the chamber itself. So obviously we need to maintain a constant mean velocity in the channel so that we are going to get proper settlement of grid particles in the grid chamber. So the wear and notches are to control the flow and to maintain the mean velocity in the channel. That is option D will be your correct answer. Option D will be your correct answer. Option D will be your correct answer. Now, as this primary settling tank questions, generally general process questions or the major type of questions is covered. So it's a very it's less important chapter, but the major important chapter is the activated sludge process. Now, before going to the questions of activated sludge process, I am just going to show you the class notes once again, so that you are having the glimpses before solving the questions. So, see, we are talking for the biological treatment process. In biological treatment process, complex generally acted upon by microorganism, and it will give you gases, energy, water, and biomass. Now, this complex plus microorganism, they will give you simple end product. What type of microorganism they are? They will be heterotrophic microorganism. They will be heterotrophic microorganism who can't produce their own food. That is heterotrophic microorganism. Now, those who can produce their own food called as autotrophic, they are not point of concern here. Now, this biomass. Biomass क्या होना चाहिए? Ideally, biomass should be the dead cells. Ideally, the biomass is nothing but the dead cells of microorganism. लेकिन it will not be the only dead cells. Some living cells will be also there. So biomass is actually dead cells plus living cells. And the process of this decomposing the thing is will be of three type: aerobic, anaerobic, and facultative. Aerobic means oxygen is must, anaerobic means oxygen absence is must, and facultative means it can happen with anyone. Now, in the aerobic process, complex will be acted upon by microorganism. In the presence of oxygen, it will produce carbon dioxide, ammonia, water, energy, and biomass. In anaerobic process, it is acted upon by microorganism. In the presence of carbon dioxide, it will produce methane, ammonia, H2S, energy, and biomass. Aerobic process is fast process, but anaerobic process is slow process. Aerobic process is fast process, but anaerobic process is slow process, and whatever is fast process will be less efficient. So obviously anaerobic process is more efficient as it is slow process. And the aerobic process will be of two types: suspended growth process and attached growth process. This aerobic process will be of two types: suspended growth process and attached growth process. And the example of suspended growth process, those details are we have already discussed. Example of suspended growth process is activated sludge process. Activated sludge process, what we are doing, we are putting the microorganism in a tank called as aeration tank, supplying the oxygen. And after certain time, the whole water will be transferred to a secondary sedimentation tank, from here where you are going to get the biomass or sludges, and certain portion of sludges will be reactivated once again. Certain portion of sludges will get reactivated once again, and that's why it is called as activated sludge process. We have gone for the schematic diagram, and that these are the design parameters. First of all, F by M ratio. I am telling you, after we quickly finish this, we'll go for the problems itself. That is F by M ratio. It is BOD loading rate or organic loading rate or volumetric loading rate. By M ratio is QYI by Vx. I have told you, you have to go with the ideal unit itself. Otherwise, it will be a problem. So for F by M, Q will be in meter cube per day, YI will be in milligram per liter, V will be in meter cube, X is in milligram per liter. BOD loading rate or organic loading rate or volumetric loading rate is VL. removal efficiency, detention time, everything is there. Mean cell residence time or theta c or MCRT is defined. Sludge volume index, importance of sludge volume index is also discussed. Recycling ratio, problem we have solved. Then we have gone for some special cases of activated sludge process like conventional ASP and modified ASP, trapper aeration, extended aeration, stepped aeration, contact stabilization. This is for tapered aeration. This is stepped aeration. This is extended aeration. This is contact stabilization. Operational problem of activated sludge process, rising of sludge and bulking of sludge. These are we have discussed. Now we go for the problems. First question. Question number 1. A town produces sewage of 15 to 10 to the power 6 liters per day with BOD of 180 milligram per liter. Taking permissible volumetric organic loading rate as 550 gram find out the volume of aeration tank. Find out the volume of aeration tank. Solve this question. Question number 1. So the town produces, Q is given as 50 into 10 to the power 6 liter per day. Volume of, you need to find out what is the notation, what is given, YI, BOD, 180 milligram per liter. Permissible volumetric loading rate, VL, is 550 gram per meter cube day. The part is, we have to always follow the ideal unit path. So that is 550 into 10 to the power minus 3 kg per day meter cube. So VL is what? For VL, Q has to be in MLD, YI will be in milligram per liter, and V should be in meter cube, right? So volume will be in meter cube when Q, that is in MLD, 15 into 10 to the power 6 is 50 into 180 by 550 into 10 to the power minus 3. Then what will happen? You will get the final answer at the ease. You don't have to bother about what unit, do not bother about the units there. So V will be equals to 16363 meter cube. V will be equals to 16363 meter cube. Okay. Now, so question number 2. Our town produces sewage of 50 into 10 to the power 6 liters per day with BOD of 180 milligram per liter, taking F by M as 0.5 day inverse and MLSS as 1800 milligram per liter. The volume of aeration tank required is. Question number 2. So a town produces sewage of 15 to 10 to the power 6 liter per day with BOD of 180 milligram per liter, taking F by M as 0.5 day inverse and MLSS as 1800 milligram per liter. The volume of aeration tank required is. Now F by M will be in day inverse. What is the ideal unit line where Q has to be in meter cube per day, yi will be in milligram per liter, by B has to be in meter cube, and X has to be in milligram per liter, right? That is the ideal unit line, and X is MLSS given 1800 milligram per liter. So Q will be in meter cube per day. How much? So it's 50 into 10 to the power 6 liters. So 10 to the power 3. Yi will be in 180 milligram per liter by volume is that we don't know. We need to find out. And X is 1800, where F by M value is given as 0.5 day inverse. From here, if you calculate V, it will be 10,000 meter cube. See, for both the question, for question 1 and 2, you are actually finding out the volume. But for question 1 and 2, your approach is different. In the first question, we have taken the path of volumetric loading rate. The second question, we are taking the path of F by M ratio. So the approach is different. That is important. The approach is different. That is important. Okay, that important that what is there, what you need to find out. You have to be very careful about that. Let's go for question number 3. The MLSS concentration in an aeration tank is 2000 milligram per liter, and sludge volume after 30 minutes settling in a 1000 ml cylinder is 176 ml, then SVI will be solve it. Take some time and solve it, then I'll solve. So what is SVI? It's actually not V, it's Y. SVI is Y in milliliter by X in gram. So 176 by 2 ml per gram, that is equals to 88 ml per gram will be your SVI value. Okay. Now we are going for a common data question. 4 questions will be there. 4, question number 7. The reason I'm solving this type of question, because then you can understand all the design parameters. Another problem I will solve where all the design parameters in all aspects you will be going through. And average operational data for conventional activated sludge treatment is as follows. I'm intentionally writing the thing statement so that you can identify which parameters, which notations we are talking about. Now, right into the questions. Question number 4. Arrest period in hours. I'm not writing the options. Question number 5. F by M ratio in day inverse. Question number 6. Efficiency in BOD removal. Question number 7. Theta sludge edge. This thing you need to find out. That is a statement. An average operational data for conventional activated sludge treatment is as follows. Wastewater flow rate given 35,000 meter cube per day, volume of adjacent tank, influent BOD, effluent BOD, MLSS concentration, effluent suspended solid, waste sludge suspended solid, quantity of waste sludge. If you are not able to see this, waste sludge suspended solid is 9700 milligram per liter and quantity of waste sludge is 220 meter cube per day. Write down the things in your copy and then try to solve the questions. Questions are given this. Aeration period, F by M ratio, efficiency and theta. These 4 things you need to find out. Your first job is to identify what are the parameters mentioned here. Your first job is to identify the parameters mentioned here, like wastewater flow rate means what? It's Q only. Volume of adjacent tank is V. Influent BOD concentration, it's YI. Effluent BOD concentration, it's YE. MLSS concentration is X. Effluent suspended solid is what? XE. Waste sludge suspended solid, it's underwater flow rate XU, and quantity of waste sludge is QW. It's QW. Now you can easily solve. I'm just going away so that you can understand the thing. I'm here only. Just to give you the essence, whatever written here. So hope you got it. Now we need to solve the questions. Aeration period in hours. Aeration period in hours. Question number 4. Addition period is detention time. In hours is V by Q. V is given as 10,900 by 35,000. 10,900 by 35,000. But that will be in day. So in 24, it will be 7.47 hours. 7.47 hours. Then F by M ratio, where Q has to be in MLD. No, sorry. Q has to be in meter cube per day. Don't mistake. Don't do this type of mistake. Q has to be in meter cube per day. Yi in milligram per liter. V will be in meter cube. And X will be in milligram per liter, right? So Q 35,000 meter cube per day only given directly, 35,000. Yi value given as 50 milligram per liter. 50 milligram per liter. Then volume 10,900 meter cube into X is how much? MLSS 2500. 2500. 0.32 day inverse. 0.32 day inverse. Efficiency Yi minus Ye by Yi into 100. So what is influent BOD concentration here? 250. What is effluent BOD concentration? 20. 50 minus 20 by 250 into 100. How much it will be? 92%. 92%. Now seventh one, asking for sludge theta C, that is what? Vx by QWXU plus QEXE. Now V given, X given, XU given, QW is also given, Q is not given. No, if Q is not given, if Q is not given, quite obviously there will be another formula that which we use, that is theta C is equals to Vx by QWXU plus Q minus QW into XC. V is how much? 10,900. That's in meter cube. So it has to be in milliliter into 10 to the power 3 liter into milligram per liter. X is how much? X is given as 2,500 milligram per liter. So now it is in milligram whole by QWXU. What is QW? 20. It's 220 into 10 to the power 3 liter into XU. XU value is given as 9700 milligram per liter. So it's now milligram per day plus 35,000 minus 220 Let me write down freshly. Plus 35,000 minus 220 into 10 to the power 3 into what is XC? XC is also provided, right? 30 milligram per liter. From here, you are going to get the value as 8.58. Obviously, it will be in days. 8.58 days. Have a look. Let's solve it. The next question. Question number 8. If the SVI is 88 ml per gram for an activated sludge process, then the concentration of the return sludge will be then the concentration of the return sludge will be. Very basic question. Very basic question to solve. Question number 8. We know that concentration of return sludge means they're asking for XU, right? So XU in milligram per liter, that is actually equals to 10 to the power 6 by SVI in ml per gram. It will come as 11364 milligram per liter. It will come as 11364 milligram per liter. That is SVI. Let's go for question number 9. Let's go for question number 9. And question number 10. It's a common data question. GATE 2012 question. Question number 9 and 10. Common data question. An activated sludge process is operating with the following data. Flow rate, 500 meter cube per hour. Influent BOD YI 150 milligram per liter. Effluent BOD 10 milligram per liter. Then detention time given as 8 hours. Mean cell residence time given as 240 hours. Volume given as 4000 meter cube. MLS is given as 2000 milligram per liter. See here, this notation is not given. Because from the notation we can find out the formula. They have given the statement. So please don't forget which notation is used for what type of parameter, what type of statement. That is also important. I have told you the activated sludge process is a vast area to understand. But for your gate process, the way I am going to deal with it, you have to follow it. Then you can effectively and efficiently solve the questions in for gate and IES. Question number 9. The F by M ratio. And question number 10. The mass in kg per day. The mass of solid wasted from the system. Solve these two questions. Question number 9 and 10. Solve these two questions. Question number 9 and 10. Okay. So first they are asking for In the question number 9, first they're asking for the F by M ratio. What is F by M ratio? It's QYI by Vx, where Q has to be in what? Meter cube per day. YI will be in milligram per liter. Volume will be in meter cube, and X will be in milligram per liter. So what is given? Q is given as 500 meter cube per hour. So 500 meter cube per hour into 24, then it's only meter cube per day. Understood? Then YI given as 150 milligram per liter. So 150 by volume given as 4000 meter cube, and X given as 2000 milligram per liter. From here you will get the value as 0.225 day inverse. 0.225 day inverse. 0.225 day inverse will be your answer. Now question number 10. What they have asked? The mass in kg per day of solids wasted from the system. Now there is no direct formula to find out the mass wasted per the system. But if you remember the theta c formula, that is Vx by QWXU plus QEXE, right? This whole segment, the bottom part of this fraction is the mass of solid. If you remember, wasted per day. If you remember, see, the bottom part is actually mass of microorganism wasted per day. The whole bottom part they are asking. The whole bottom part they are asking. Okay. The whole bottom part they are asking. So eventually, what we need to do? So our mass of solid, our mass of solid wasted per day will be Vx by theta c, where V is given as 4000 meter cube. So 4000 into 10 to the power 3 in liter. X is 2000 milligram per liter. 2000. So it's in milligram. And theta c will be given as 240 hours. So theta c can be defined as 10 days, as 240 hours it is mentioned. So that will be milligram per day. So it is going like this: 800 in 10 to the power 6 milligram per day. But as in the question they're asking in kg per day, it's 800 kg per day will be your final answer. 800 kg per day will be your final answer. Question number 13. 800 kg per day will be your final answer. Okay. Sorry, it's 10. Now, question number 11. Question number 11. The dominant microorganism in an activated sludge process are option A, aerobic heterotrophic, option B, anaerobic heterotrophic, option C, aerobic autotrophic, option D, sulfur bacteria. GATE 2014 question. Try to understand this. Activated sludge process is obviously it's an aerobic process. It's an aerobic suspended growth process. So A and C is there, B and D is already rejected. Now going for the type of microorganism, of course it has to be heterotrophic microorganism. Why? Because if it is autotrophic microorganism, they will produce their own food. And if the microorganism is producing their own food, then they will not grab your pollutant as their food. So aerobic heterotrophic will be your final answer. Option A. Option A will be your final answer. Option A will be your final answer. Question number 11. Option A will be your final answer. Now, we are going for the last question. Again, that question defines every design parameters. The question requires every design parameters of activated sludge process. Each and every, for you to solve this question, you need to know all the hooks and crooks of this activated sludge process. Okay. So that is the final questions. If you are able to solve that particular questions, everything is clear for activated sludge process. So the operational data for activated sludge process is given herewith. Flow rate, it's 10,000 meter cube per day. Influent BOD, 150 milligram per liter. Effluent BOD, 30 milligram per liter. MLSS, 3000 milligram per liter. MLVSS, it's 10,000 milligram per liter. Theta C, 10 days. F by M ratio 0.2 inverse. That is the data given. We will identify later that what data is actually representing what schema notations. Need to find out. Let me write down first everything under the sun for activated sludge process. Find out. क्या चाहिए? पहला है वॉल्यूम ऑफ एरेशन टैंक, सेकेंड एरेशन पीरियड, थर्ड BOD removal efficiency, fourth volumetric loading rate, five mass of solid wasted per day, six volume of solid wasted per day, SVI, recycling ratio, rate of return sludge, this thing you need to find out. Have a look, try to solve. The operational data for ASP is given here with. So what is given plus find out the notations. Then flow rate. So it's Q only. Influent BOD it's YI, it's YE, it's X. MLVS is XU, and rest of the things are provided. So let's solve the question. First of all, volume of addition tank. So first is by M is provided, right? So volume of addition tank will be volume in meter cube. That is Q in meter cube per day. YI in milligram per liter. by F by M in day inverse. Directly I'm writing down. And X in milligram per liter. So what is volume? Q is given as 10,000 meter cube per day. YI is 150 milligram per liter. By F by M is 0.2. X is provided as 3000. 2500 meter cube. That will be your volume. Second question. Aeration period, retention period will be V by Q, that is 2500 meter cube by 10,000 meter cube per day into 24. It will be 6 hours. That is retention time. Question number 3 is BOD removal efficiency. It is YI minus YE by YI into 100. So it's given as 150 and 30. It's 150 minus 30 by 150 into 100. It's 80%. Question number 3. Question number 4. They're asking for volumetric loading rate. VL, for VL, what should be the unit? Q should be in MLD. Hope you remember. And Q into YI is that should be in milligram per liter by volume in meter cube. So it is 10,000 meter cube per day. So it's 10 MLD into YI is 150 by 2500. That is 0.6 kg per day meter cube. 0.6 kg per day meter cube will be the volumetric loading rate. That's question number 4. Let's go for question number 5. Mass of solid wasted per day we have already seen. That is Vx by theta c only. Mass of solids wasted per day, that is Vx by theta c, where V is provided as 2500 meter cube into 10 to the power 3. X is 3000 milligram. That's in milligram. Theta c is given as 10 days. It's 750 kg per day. (750 kg per day) mass of solid wasted per day. Question number 6 is given as volume of solid wasted per day. So what is mass of solid? What is kg per day? It's kg per day is nothing but mld into milligram per liter, right? So QWXU plus QEXE, that is equals to 750 kg per day. Now QE and XE both are not provided, we will take it as 0. So QW, XU, so QW in MLD into XU in milligram per liter, that is equals to 750 kg per day. So what will be your QW in MLD? It's 750. What is XU? 10,000 only. Point 075 MLD, that is 75 meter cube per day. 75 meter cube per day. Okay. Question number 7. It's done. SBI. Question number 8. Question number 8 is SBI. SBI is 10 to the power 6 by XU. 10 to the power 6 by 10,000. It's 100 ml per gram. That is question number 8. Sorry, question number 7 it is. Sorry. Question number 8 is recycling ratio R, which is nothing but X by XU minus X into 100. So X is given as 3000 by 10,000 minus 3000 into 100. It's 3 by 7 into 100. 42.8%. Last question, rate of return sludge. Rate of return sludge R, QR. It's actually R into Q. That is 4280 meter cube per day. Clear? So they are the general type of questions generally you can expect from activated sludge process. All end over there. Just have a look what are the questions we have solved. You follow the line of, always following the line of what? The standard unit. Last question it is. So don't forget to subscribe the YouTube channels. Let's crack GATE and EAC. My code is SEN10. My code is SEN10. For maximum discounts, you can apply the code SEN10 and join our Telegram group for latest updates on our upcoming videos. Hit the bell icon for notifications. My code is SEN10. And next Unacademy Combat goes live on . 26.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
So next combat will go live on January 26, 2021, 6 p.m. And once again, I'm telling you, don't forget to apply my code SEN10, ACN10. Don't forget to apply my code SEN10. And please subscribe the YouTube channel and hit the bell icon for notifications and join our Telegram group for latest updates on our upcoming videos. Thank you. So we have completed the process of wastewater engineering. All the chapters questions are also done. There will be class where we will go for the problems of air pollution and solid waste management. That will be done on tomorrow, and day after tomorrow the rest of the part of disinfection process, some questions of groundwater treatment and distribution system will finish our whole environmental engineering chapter itself portion. Let's crack for gate 2021. See you tomorrow.